Beer's Law lab now, and we'll be able to investigate the relationship between concentration and absorbance. So when you click on the link, you have two choices. I want you to get to the Beer's Law lab, and here we go. So this is a cuvette. A cuvette is going to be filled with some liquid, some solution. In the lab that you do, you're going to have the potassium permanganate, and you want to make sure that the wavelength is preset to 544 nanometers. You can actually drag this and measure the path length here. The path length is going to be 1 centimeter. That shouldn't change. You can change it. Don't. Please don't. That would change it. Just leave that alone. This is your meter. You can set that to absorbance. You can measure transmittance or absorbance. We're gonna do everything in absorbance, and then you just have to click on this. This is your light. So light is passing through here, and this is a detector. It's going to tell us we're going to be able to figure out how much light is being absorbed, how much light is being transmitted, and we're going to relate that. We're going to use Beer's law to help us figure out what the concentration is here. Or actually, we're going to make a calibration curve, and we're going to have known concentrations, and then you're going to measure the absorbance, and then we'll be able to plot a graph, and we'll use that graph to help us figure out what the concentration is for some unknown solutions. So I don't want to do the lab for you. So instead of doing potassium permanganate, I'm going to do copper sulfate instead. So you can see the wavelength changes. I want you to do potassium permanganate. I'm going to just do the copper sulfate. So when this is on 0, concentration is 0, this is how you change the concentration. And you can see it changes the color of the solution as well. If it's not concentrated, it's going to be pretty light. And then as you increase the concentration, it gets darker. You can see what happens with the absorbance as well. When it's really light, it's not absorbing much. When it is much darker, then it starts to absorb more. So the more concentrated you're going to, solution will absorb more light. Less light's going to be transmitted. That's another way to think about it. So for this one, I already have the data worked out, but I took it every 25 millimolar. Here's 0.24 millimolar. Sorry, absorbance of 0.24. Changed to 50, 0.48. So I've already recorded values for these. Here we go, over here. So I did it in Excel. The first thing you want to do is probably copy record all your data on your data sheet. Here are the concentrations you're going to use. So you change the concentration, and then you're going to read the absorbance off of the meter. Just make sure, I lost it. Make sure that you don't change this meter. If you put this over or somewhere else or in here, you're going to get a different reading. You want it at the end, outside of that, after it passes through the solution. Okay, so I've collected all my data. Here we go. You're going to record all of your data on your data sheet, and then you're going to also cut and paste this and put it right in Excel if you want to. And you'll want to, because we're going to make a calibration curve. So that is plotting the absorbance versus the concentration. So I have my values in here. I just had to type these in. I'm going to highlight those. I'll just drag that and copy. Then I go to insert, and then over here, this little graph scatter plot, and boom, there we go. And then I always want to check to make sure that I have the right things placed in the right places. So on the bottom, on the horizontal axis, I want to have the concentration, and on the vertical axis, I want the absorbance. This is our independent variable. I'm changing the concentration, and the absorbance depends on the concentration. So this is my dependent variable. This is my independent variable. So I want to make sure that I have the right things on the right side, and we'll label them. So on the bottom here, I have concentration, and on this axis here, I have absorbance, and you can say this is your calibration curve. So how did I get there? Let's go back one more. When I click on this graph over here, I have the plus sign, and then I go over to titles, and then you can add those titles. Of course, now I have to do it again. So this is concentration, and this is absorbance. And then just check that to make sure. So my concentration goes from 0 to 200. Here my concentration goes from 0 to 200. Absorbance goes from 0 to 1.92. yep, there's our highest one is a little bit less than 2. So that makes sense. This is absorbance, this is concentration. Good. The next thing we want to do is make a add a trend line. So I click on any of these dots. I right click on any of those dots. Great. Now I left click and go, sorry, I right click and I go to add a trend line. Add a trend line. Scroll down to set the equation. Not set the intercept, set the equation on the chart. There we go. There's our equation. And if we look at that, this is our slope, the 0.0096. So y equals mx plus b. This is our slope. That's the constant that we were looking for. Our intercept is basically 0. It's 7 times 10 to the negative 16. That's 0. I mean, you could, that's 0. That is what it is. So I'm going to use this information now to help me figure out what these concentrations are. So I can look on this graph and say, all right, well, when my absorbance is 6.1, all right, my absorbance 6.1 is about here. I'm going to draw a line over and try to figure out where that is on the graph. Or I can use math to do that. So let me include my slope over here. So you can find your slope. We already know that it's 0.0096. Here's another way to do it. We say equal slope and then put in all of your y values and then your x values. You don't have to do it that way. We're going to get the same number from the graph. I just want to show you how you can calculate slope using Excel without making the graph. I don't have to worry, our intercept is going to be 0, so we don't have to worry about that. Minus 7 times 10 to the negative 16. It's a really, really, really small number. That's 0.00000, like lots of zeros and then a 7. So to find the concentration, what equation do I have here? I have y equals mx plus 0. The x here, that is our x value, that's our concentration, and the y is the absorbance. So what I'm going to do over here to find concentration, I basically have, like y equals concentration, slope times concentration, right? Slope times concentration. So if I were to solve that equation for the concentration, I just have concentration is just going to be the absorbance. I don't know why I said y. Y over here, that is the absorbance, right? So absorbance equals slope times concentration. So concentration is just going to be the absorbance divided by the slope. Absorbance divided by slope. So here I'm going to take the absorbance and I'm going to divide that by the slope. You can do that all the way around. Equals absorbance divided by the slope equals absorbance divided by the slope. Again, your numbers are going to be different because you're doing a different compound. So these are my absorbances, these are my concentrations, and we can double check that on this graph as well. So we have at a concentration of 64, so 64 on my x-axis, and we're over here. If I draw a line up here, see where it hits the graph and draw a line over, yeah, sure, that could be around 0.61. 115, it's going to be around here, draw a line up, and yeah, that's between 1 and 1.25, sure, so 1.1 makes sense. And then the last one, 177, that's over here-ish, about-ish. Draw a line up and over, yeah, you're in the right range. So these numbers make sense. You can just always verify using that graph. And you want to show, you could show this work if you do it in Excel, like this part in Excel. You can show your formulas. You can go under formulas, I think, and display, show formulas. There you go. And that'll show you what you typed in. Get out of that. And then just looking at our data sheet. So you have for this one an abstract, an introduction, conclusions, and then you're going to fill out this table, put your unknowns in here. Make sure when you have your abstract and your conclusions that you say what you got for your unknowns. What did you find the concentrations to be? So they were, whatever, 3 there. Make sure you show your calibration curve, and then either if you did this all on Excel, just take a just embed the formulas there, or just write out how you found those concentrations.